Okay, so to get back into it with what does the math actually look like, right? Well, we need to, like always, like we did last unit, separate into x and y components, right? And then we can add x's to x's and add y's to y's, being careful that if they're in opposite directions, we give them the opposite sign. Okay, before we get to actually adding them, let's just remind ourselves how we separate them. Okay, so in that previous example, both forces were along conveniently either north, east, south, or west, right? It was north and east in that previous example. So we didn't actually have to separate them into the y and x components because they only had either a y component in the case of the one force or only a x component in the case of the other. However, one force can have both components. So let's kind of just remind ourselves of how we do that. So I'll kind of use blue to be x, I'll use red to be y, and then purple will be the resultant kind of force, or the force. I guess it's not a resultant force because it is the force here, right? But we could think of the force as the result of its x component and its y component. Okay, so if a box is pushed with a force of 25 newtons at 74 degrees south of west. First of all, what does that angle mean? 74 degrees south of west. So we're going to start south, right? Sorry, we're going to start west. If we're south of west, we start it at west and we go south of it, right? How far south of it? 74 degrees. So that's pretty far, right? That's only, that's a pretty big angle. So that would be 74 degrees south of west, okay? And so when we go to draw our force, we would say we're 74 degrees south of west, okay? Again, this is west, and we've gone 74 degrees south of it. So what is the x component of this force? This force that is 25 newtons. What are the x and the y components? Well, the x component, right? If I push from here all the way to here, in just the x-axis, what am I doing? Am I pushing, west or east? Well, in just the x-axis, I'm pushing west, right? That is the x component of my force. Now, in just the y-axis, right? In just the y-axis, what is pushing on this angle here? What is it like doing? Is it like pushing north or like pushing south? In just the y-axis, right? That is the y component of my force, right? So if I were to push this hard to the west and this hard to the south, I would end up with the same result as pushing at 25 newtons, 74 degrees south of west. Problem is, what are those? Well, don't forget, we have our angle here, right? This angle is 74 degrees, okay? And to separate into components, we always kind of use our SOHCAHTOA, right? So let's take a look. If I want to find fx, okay? If I want to find fx in triangle terms, what side is this, right? What side is this in terms of triangles? Well, x is the adjacent side. Okay, great. What else do I have? I have this side here. This is a triangle, right? This is the x-axis, this is the y-axis. So by definition, that's a 90-degree angle there, right? So across from the 90-degree angle, we have the hypotenuse, the longest side, okay? Which makes sense. How could the force's components be larger than the force itself, right? The components are what make up the force. So again, I have the adjacent side, I want the adjacent side. I have the hypotenuse out of SOHCAHTOA. What helps me there, right? If I've got adjacent and if I want adjacent and I've got hypotenuse, I'm going to have to use cosine to get my x here, right? So we would say cos of 74 degrees equals adjacent fx over hypotenuse, f, okay, f. And so to find fx, right, what's happening to it now? Why is it not isolated? Well, it's not isolated because it's being divided by f. So to undo that, multiply, do the opposite of dividing by f, multiply by f. Do that to both sides, and there we go. fx, right, the x component of our force is equal to f times cos of 74 degrees, right? Kind of losing the color coding there, but so we know f, we know what the cos of 74 degrees is. That's just a number. Punch in your calculator. So fx equals 25 newtons times cos of 74 degrees. And if you punch that in, you will get okay, to two significant digits, I got 3.3 newtons. Okay, now here's the thing. There's sometimes you have to do the interpretation. Okay, the math won't always just spit out the answer for you. That's why diagrams are so helpful here, right? So which way is Fx? Because it still is a force, which means it still is a vector, right? So that means it has a direction. So which direction is Fx? Well, we can tell from our diagram and from our knowledge of the situation that in the x-axis, that force is to the west. Okay, now to get Fy, right, we have a few options, but probably the safest way, the way that doesn't use anything we've calculated already ourselves, is to just say, okay, I've got theta, right? I've got this angle here, 74 degrees. Fy would be opposite to that angle, right? Opposite, and I still have the hypotenuse that they gave me. So opposite and hypotenuse, I want opposite, I've got hypotenuse. That means so is going to be useful to me here, right? So katoa. So sine of theta, doing red for y, equals opposite over hypotenuse. The opposite is Fy over, once again, the overall force, right? The sum of its components. Okay, so just like before, multiply both sides by F to get Fy by itself, and Fy equals, lo and behold, F sine theta. Okay, so Fy equals 25 newtons times the sine of 74 degrees. So the y component of the force is going to be, I got 24 newtons to two significant digits, okay? Now again, we have to rely on our knowledge of the situation here. The math won't always just spit out the direction, okay? But we got our heads screwed on tight, right? We can go back and look, right, okay, so which way is Fy? It has to be south, right? Even if I hadn't drawn those components in, which we should if we're solving for them, right? But even if I hadn't, you can tell by looking at this vector, is that going to be a south or a north, right? Does that have a southern y component or a northern y component? Well, it's pushing kind of south and west, right? So the y part is the south part. Okay, move on to this one. We'll separate this into its component. What if the wind is blowing a boat with a force of 14.5 newtons at 35 degrees east of north? So first things first, okay, let's draw our, we need to draw our force to kind of picture it. But to draw it, we need to figure out what is this 35 degrees east of north going to look like, okay? So 35 degrees east of north. Where do we start at if we're going east of north? Okay, do we start at north or do we start at east? If we're going to go east of north, okay, we need to start at north and go east of it. How far east of it do we go? Well, 35 degrees. So halfway would be 45, so a little bit smaller than that. Okay, that was what our force is roughly going to look like, and that's 35 degrees. Okay, so if the wind blows a boat with a force of 14.5 newtons, we can now draw our F, our force, right? So force looks something like that. Okay, so F equals 14.5 newtons. Okay, and so let's separate that into its components, or let's draw its components out, okay? So if I'm going on this angle here, what is that like doing in the y-axis? Well, it's like doing that, right? It's like going straight up, okay, just in the y. So that would be Fy. Now in the x-axis, what have I done in the x-axis? If I push on this angle, it's the equivalent to, in just the x-axis, pushing like that, right? And so when I add Fy to Fx, overall, I've done this, right? Just like when we go up to the dog here, if we pull the dog like this, it's the same as pulling it sideways and upwards at the same time when we pull on that angle there, right? A force is the sum of its vector components, okay? And so I've chosen to draw it like this. I'm just gonna, I'll delete it in a sec here, but I do want to show you something. What if would I be wrong to have drawn it like this? Fx, and I know it's getting messy. I'm gonna get rid of it in a sec, but would that have been wrong? Is there anything wrong with that? Okay, and the answer is no. That is still the x and the y components, right? If you look, this is the same thing as this. This is the same thing as this. It doesn't matter which order you add them in, okay? You still get the same result as long as you go tip to tail properly. The reason I've chosen to draw it the way I did and not the second way, okay, is because of the angle I was given. So it just makes a little bit less work for me to draw it this way because I already know that's 35 degrees. However, there would be nothing wrong with just doing a quick little calculation saying, okay, well, if that's 35 then, and this whole thing is 90, then this must be right here, this must be 90 minus 35, okay, which would give you 55, right? So nothing wrong with that. It's just a little extra calculation, so I chose not to do it, okay? So I'll get rid of those, that alternate version, but just wanted to clarify if you're kind of worried about how do I know which way to draw it. The answer is it's fine as long as you think about the angle correctly after too. Okay, so I'll draw that angle back in. That is 35 degrees. And so to separate this into x and y components, okay, again, just think about the sides you have and the sides you want. So with our SOHCAHTOA, okay, let's first do x. So if I'm x, right, in triangle terms, right, in other words, adjacent, opposite, and hypotenuse, what is x, fx to theta? Well, it is opposite of theta, right? I have the hypotenuse, so opposite and hypotenuse, hey, that's my sine, right? That's my sine ratio, opposite hypotenuse. So sine of theta equals opposite fx over f, right? So by the same manipulation we just did, then we have that fx equals f times sine of theta. F is 14.5 newtons. And theta we know is 35 degrees. Okay, so if you plug that into your calculator carefully, you should get that Fx. I got to 3 significant digits, 8.32 newtons. Okay, great. Force is a vector though. What am I missing? Direction, right? I've got magnitude, but I don't have direction. So that's how hard it's like pushing in the x-axis. What direction would you be pushing this in the x-axis? So that's where our diagram comes in very handy, right? Thinking about it. Well, that's going to be to the east, right? So the x component is purely to the east, which kind of makes sense, right? If our overall force was east of north, what is the x part? Well, it's east. What is the y part? Well, it's north, okay? But our diagram supports us on that as well. All right, let's look now at the y component, fy. So to this angle is y adjacent, opposite, or hypotenuse. Well, it's close by, right? Adjacent. Adjacent means next to. So then, whoops, not sine. Okay, so I have adjacent, hypotenuse. Could I use tan? Yes, because I found fx. Could I even use Pythagorean? Yes, because now I have two sides. However, I like to use the thing that requires me to use the fewest calculated values, right? I calculated fx, so let's just go ahead with the numbers they gave me. So cos theta equals fy over f. And once again, right, same manipulation really. F cos theta times f, which equals cos of, the angle is 35 degrees, and the force is 14.5 newtons. And so Fy equals, I got 11.8 newtons. Which direction? Well, going back to our diagram, Fy is north. Okay. So a force of 60 newtons at 10 degrees from the horizontal. So what does that mean? It means, well, if you're looking from the horizontal, we are 10 degrees from it, okay? Usually that means above it, though sometimes they might say 10 degrees below the horizontal. Usually if they say 10 degrees from the horizontal, that means above it, okay? So 10 degrees is pretty small, right? 10 degrees is fairly small. So I'm thinking roughly, ballparking, it's going to look something like that. That's roughly what our force is going to look like. So when we go to draw it, okay, we'll draw it fairly flat, so to speak, fairly close to the x-axis. So F equals 60 newtons. Okay, now try this on your own. Okay, draw in the x and on the y components. So I want you to pause, try this. Okay, don't just watch me do it. Like I say, it's riding a bike, right? You can't just watch someone else ride a bike. You got to get on the bike yourself. Now, if I draw them in, I've got fx there, right? What is y? Well, tip to tail, there's fy. Again, I could have drawn it the other way, but I chose to do it that way because I was already told 10 degrees from the horizontal, right? Not 10 degrees from the vertical, 10 degrees from the horizontal. So now I know that angle already. I don't even have to do any extra math, and I'm set up to go. Okay. So, SOHCAHTOA, right? I want fx. That is the adjacent side, and I have the hypotenuse. So I'm going to use my cos. I'm just going to kind of show a little less work than I have been because it's kind of, you might be getting the pattern here, right? Cos theta equals fx over f. If you want to kind of unmanipulate that, you can see my starting point there, okay? I'm just kind of speeding up here a bit. So fx equals 60 newtons times the cosine of 10 degrees. And I'm getting that the x component of that force would be 59 newtons. Okay, what direction would I give here? How would I represent the direction of this? So we don't know what the horizontal is. Is it northeast, southwest? Is it right? We don't actually know, right? So all I can really say is, well, it's at, in our standard kind of angle position, our Cartesian coordinates, it's here, right? What angle would we say that is? That would be 0 degrees, right? That's 90, 180, 270. Okay, so that's at 0 degrees. What about Fy? Again, Fy is opposite to our angle. So Fy equals, okay, F times sine theta. If you're not sure how I got there, start with your SOHCAHTOA and manipulate. Okay, Fy equals our force being 60 newtons times sine of 10 degrees. Just make a prediction right now. What do you think? Based on our diagram and based on the angle here, do you think this number is going to be larger or smaller than fx? Right? Good idea to think about what you're getting as you go. Okay, so I got that Fy was 10.4 newtons, right? So yeah, okay, smaller. That's probably, whoops, that's too many significant digits. Okay, 10 newtons, okay. It should be smaller, right? This is a shallow angle. It's got a big x component, a small y component. So that kind of makes sense. Fy is 10 newtons. Notice the Fx is 59 newtons, right? So that's a big chunk of our 60 newtons can kind of come from there. So Fy is 10 newtons. What is the direction there? Well, which way is Fy going in terms of our Cartesian coordinates based on our 4 quadrants? Well, it's straight up, right? So that would be at 90 degrees. Okay. So again, pause the video, try this one on your own, okay? And then come back. If you want, you can, if you get stuck, watch my solution. If you just want to skip ahead to the answer, that's fine, okay? But I do want you to try this one on your own. So a force of 45 newtons acts at 200 degrees. Now, what does that look like? Those are definitely Cartesian coordinates, right? So I want you to think about where would be 200 degrees. We kind of drew it out here already, right? So if this is 0, as I move to here, I've now gone 90, okay, 180, and then 270. So it's somewhere between 180 and 270. It's definitely a lot closer to 180, right? In fact, it's 20 degrees off. If I go 180 and then I go another 20 degrees, I've hit 200 degrees. So roughly that's what my force is going to look like. Okay, something like that. It might be a bit too steep, but there's my force of 45 newtons. Okay, I'm gonna choose to draw it this way. However, this one, there's kind of two ways to think about it, right? I Okay, so the direction of my force would be, would be roughly something like that. Okay, and again, you can choose to draw this in a couple ways, but the way I've chosen to set it up there is kind of matching this thing here, right? So my x component would be along here, that's fx, and my y component would be vertically down like that. Okay, the reason I chose to draw x then y instead of y then x, right? I did x then y instead of y then x is because I kind of worked it out in my head that this angle was 20 degrees. Because if that was 180, then I would have to go 20 more to get to 200. You also could have thought, well, that's 270. So between 200 and 270, there's 70 degrees. Okay, but I'm choosing to do it this way. So then when we look at fx and fy again, fx is adjacent or opposite, right? Which one? It's adjacent, right? It's closer, and I have the hypotenuse, so that means I'm going to need to use cos here again. Okay, again, if you're not sure how I'm getting to this step, just start at the beginning with your cos ratio. I'm just kind of speeding things along a bit here. Fx equals F times cos theta. Okay, so the x component of the force is going to be 45 newtons times the cosine of 20 degrees. So the x component of our force is, I'm getting 42 newtons. Which way? Which way is that? Okay, again, bring your eyes over here, kind of look at this, right? 0 degrees would be to the right perfectly, right? But that's not where fx is. Fx is actually in the other direction. It's opposite to that. It's going at 180 degrees. Okay, so that's the x component of my force. What's the y component? Well, in triangle terms, right, which side is fy? Well, it's opposite the theta there, right, the angle. So fy, opposite, safest bet is to use the hypotenuse that they gave me. So opposite hypotenuse, that's going to be so, right, sine. So fy equals f sine theta, again, because sine theta equals fy over f, opposite over hypotenuse. And then the y component of the force would be 45 newtons times the sine of, not 200 degrees, right? We got to think about the triangle we've set up here, the sine of 20 degrees. And so the y component of my force, when I do 45 times sine of 20, I got 15 newtons. Okay, if we were going on to use these numbers again, I would never round them this much right away, but I kind of know that they're my final answer, right? Now, which angle is that? Which direction is Fy acting at? Well, it's going straight down, right? So straight down, 90 would be straight up, 180 would be straight to the left. So this is at 270 degrees in our Cartesian coordinate system.